Good day, class. Let us take a look at this question on single block break. The question says that a single block break shown below has a drum of diameter 250 mm and the angle of contact 90 degree. If the operating force of 700 Newton is applied at the end of a lever and the coefficient of friction between the drum and the lining is 0.35, then we are to determine the torque that can be transmitted by the block. Now, let us start. Solution. Now, let us take a look at our given. What are we given? We are given the diameter of the drum, which is 250 mm. Then from there, you get the radius by dividing it by 2, which will give you 125 mm. Then again, we are given the angle of contact, that is 2 theta, is given to us to be 90 degree. Now, converting this one to radian, we multiply this degree, 90 degree, by pi over 180. This will be equal to pi over 180 multiplied by 90. It will give us pi over 2 radian. Then, we are given the operating force, P, which is equal to 700 Newton. Then we're given the coefficient of friction, mu, which is equal to 0.35. When you look at this, the angle of contact here is equal to 90 degree. And we already know that if the angle of contact is greater than 60 degree, then we are going to pivot the shoe. And at this point, we are going to have equivalent coefficient of friction. And the equivalent coefficient of friction, mu prime, is given by this expression, this formula, 4 mu sine theta over 2 theta plus sine 2 theta. Then we substitute the value. We have 4 times our mu, which is 0.35, sine. Our 2 theta here is 90 degree. Then our theta is 90 divided by 2, which is 45 degree, over our 2 theta here, we have converted it to radian here, which is pi over 2 plus sine 2 theta. 2 theta is 90 degree. When we press our calculator for this, we have 0.385. Then we have our Rn, which is the normal force, that is pressing the block to the brake drum. Then we also have Ft, which is the tangential braking force, Then we know that tangential braking force is equal to mu prime Rn. Then from here, we have Rn is equal to Ft over mu prime. Now let's keep this one. We will use it very soon. Then let us take moment about this point O, about the fulcrum. Taking moment about O. Now we have 3 forces here. The normal force is acting upward and to generate anti-clockwise movement, and its perpendicular distance from point O is 200 meter. Then the tangential force is acting in this direction, it will generate clockwise movement, and its perpendicular distance from the pivot point is 50 millimeter. Then the pressing force is acting downward, it will also generate clockwise movement, and its perpendicular distance is going to be this 200 plus 250. Therefore, the clockwise movement that we have here is 700 multiplied by its perpendicular distance from point O, which is 200 plus 250, then plus the other clockwise force, which is Ft, multiplied by 50, then is equal to the anti-clockwise force, which is Rn, multiplied by 200. Then from here, we have 700 multiplied by 450 plus Ft here, plus this one will be 50 Ft is equal to, remember from here, our Rn is equal to Ft over mu prime, then times 200. Then 700 times 450 will give us 315,000, then plus 50 Ft is equal to Ft over mu prime is 0.385 that we have calculated here, then multiply by 200. Then we have 315,000 plus 50 Ft is equal to, then from here when we look at this one, 200 divided by 0.385 will give us 520 multiplied by Ft. Then we collect the like terms here. We have 315,000 is equal to 520 Ft minus 50 Ft. Then we have 315,000 is equal to 520 minus 50 will give us 470 Ft. Then by making Ft the subject of the formula, then we have 331,500 divided by 470. And when we press our calculator here, we are going to get 670 Newton. Then the torque to be transmitted TB is given by the torque TB is equal to the tangential force multiplied by the radius of the drum, which is equal to 670 multiplied by 125, and this will give 83,750 Newton millimeter, 83.75 Newton meter. Thank you very much. I'll be expecting the next question.